Gas chromatography, GC, is a method of separating mixtures and is particularly suited to mixtures of fairly volatile liquids. As in all chromatographic methods, there is a mobile phase, in this case a gas, that carries the components of the mixture over a stationary phase. In this case, the stationary phase is a tube called a column, packed with solid or coated with a high boiling point liquid. The components of the mixture leave the column in order of volatility, the most volatile first. This is the complete instrument, with the computer control system on the right. The sample is injected here. From this injection port, the sample passes into the column, which is kept in a temperature-controlled oven. Columns are normally wound into a spiral to save space. This capillary column is 30 meters long. This is much shorter, about 1 meter. The properties of the column and its filling are chosen for the particular separation that is to be carried out. The components of the mixture are carried through the column by a stream of inert helium gas, the mobile phase. The more volatile the component, and the less it interacts with the stationary phase, the faster it travels through the column. At the other end of the column is a detector that detects each component of the mixture as it comes out of the column and also measures its amount. This instrument has a flame ionization detector which consists of a hydrogen flame burning in air. As a substance leaves the column, it burns in this flame, producing ions, which can be detected by measuring the electrical conductivity of the flame. The hydrogen for the flame comes from this cylinder here. Before beginning a separation, the operator must set the flow rate of the gases and the temperature of the oven. The temperature of the inlet port is also set at a level that ensures that the sample is fully vaporized, and the flame ionization detector must be lit. Here, we will separate a mixture of methanol and methylbenzene. About 0.1 microliters is taken up in a hypodermic syringe. It is then injected into the inlet port through a self-sealing rubber disc called a septum. The first peak is methanol, the more volatile component. Its retention time, that is the time taken for it to pass through the column, is about 1 minute. The second peak, with a retention time of about 1.5 minutes, is the less volatile methylbenzene. Its peak has a larger area, showing that there is more of it in the mixture. The computer calculates accurate retention times and peak areas. The area under each peak is proportional to the amount of each component. The computer calculates this. This instrument is used for undergraduate practical sessions, and samples are run singly as and when each student is ready. In this alternative instrument, the gas chromatograph is on the left, and the detector is a mass spectrometer which runs the mass spectrum of each component as it comes out of the column. This can be particularly useful when analysing an unknown mixture, as the mass spectrum can help to identify each component. The combined technique is called gas chromatography mass spectrometry, GCMS. This GCMS instrument has an auto-changer for the samples. Many samples can be loaded up and run automatically, perhaps overnight.